Section 2, Video 3. Solving by factoring and zero product property. Now these go hand in hand because you cannot use the zero product property unless your term is factored. Once it's factored, you can use the zero product property. And the zero product property states that anything times 0 is equal to 0. It also states that if you get 0 for an answer from a multiplication problem, then one of the two things you multiplied must have been 0. Because we know that 8 times 0 is 0, anything times 0 is 0, and 7 times 0 is the only way that you will get 0 as an answer. So that's an example of the zero product property, with this being the official phrasing of the zero product property. Now, how does that apply to factoring? Well, we use the same rules for factoring we've always used. Make sure it's in standard form, factor into two quantities. Now, let's look at this trinomial, for example. We can factor this, and when we factor it, we get two binomials multiplied together. Now, the zero product step here says that I'm going to take this, set each one equal to 0, and see how can I make one of them 0. Well, the first one, I'd have to plug in a 3 if I solve that for x. And the second one, I'd have to plug in a 2 if I solve that for x. Now notice, not by chance, that 2 is the opposite of what's in that parenthesis, and 3 is the opposite of what's in that parenthesis. And that causes it to become 0, which allows you to take 0 times anything and get 0 for an answer. So that's an application of the zero product property with factoring. So 3 and 2 are considered solutions to that quadratic equation, and they're called zeros. Another one, if we factor that, again, before I do so, make sure it's in standard form, which means we would have p squared plus p. I would subtract 4 from both sides, and I would get negative 56 equals 0, in which we would factor. I have p, and I'm looking for two numbers that have a product of negative 56 and a sum of 1. 8 and 7 have a product of 56, and I have to have a product of negative 56 though, so one of them has to be negative, and if I make the 7 negative, together you get positive 1. So a positive 8 and a negative 7. And I can set each one of these equal to 0 and solve to find out what would make each one 0, but I know that if I plug in a negative 8 right here for p, I will get 0. If I plug in a positive 7 right here for p, I will get 0. So these two are considered the solutions to that quadratic. And this ends Section 2, Video 3.